welcome back to Calculus 1. This time we are moving into the section for derivative of trigonometric functions, section 3.5. First, let's just take a quick look about the rules and the formulas so far we covered. Okay, the first one it is, I hope you know this is the power rule, right? Very powerful rule, or really in many ways you can say this is the most powerful rule. Derivatives of power functions in the fashion of x to the power of r. It is r times x to the r minus 1. Keep in mind the reason, partly reason, we say it is very powerful because it's r, power r can be of any real numbers. Positive integers, negative integers, and fractions, the thing is. Okay, so it will work for all kinds of power functions. And also, we didn't mention the other rule, derivative of the exponential function. It is just itself. And for this part, I guess it's just easier to remember. The exponential function, e to the x, it is the only function such that the derivative, it is itself. It is for the exponential function. And also, these rules will have to be applied precisely to either a single power function or the exponential function. So if that is the case, it may not be very helpful. And we do have some other rules. Specifically, that's the sum and the difference rule. In words, I say the derivative of a sum, it is the sum of derivatives. Similarly, difference rule, derivative difference, it is difference of derivatives. The constant multiple rule simply tells us the derivative of a constant times the function. It is the constant times the derivative. And more importantly, or somewhat more complicated, we do have the product rule and the quotient rule. And again, I would ask you to try to remember both rules, product and the quotient together, because I think they do follow the similar arrangement here, right? Let's take a quick look about the product rule. U times v, derivative of u times v. It is u prime v plus uv prime. That is the product rule. Then for the quotient rule, well, we are still using notation u and v. U prime v and uv prime in the same order. And for the product, we take the sum. For the quotient, we take the difference. Certainly for the quotient, we do expect the new denominator. So the denominator, it is the original denominator squared. Product rule and the quotient rule. And these were covered before, so for now, they are just for reviewing purpose, but really, hopefully you know, in order to proceed or in order to be successful in calculus, you are going to know all those rules, so far those rules very, very well. Okay, let's move to the topic of trigonometric functions. And actually, I still have a bunch of things to review for trigonometric functions, a lot of things. First of all, just to clarify, trigonometric functions, they are for angles, right? So to clarify what is an angle, and formally we consider angle is formed by rotation. Look at this part of the graph, okay? You rotate the positive side of the x-axis, you could rotate along the counterclockwise direction or clockwise direction. When the angle it is formed by rotating around the counterclockwise direction, it is a positive angle. And then clockwise direction, that is a negative angle. And also you can rotate an angle multiple rounds, okay? You form several complete revolutions. So I'm saying you may have some huge angles, an angle greater than 360 degrees and 721,000. It could be something very huge, okay? And also, I said very quickly, there's a thing about the angle, the measurement of an angle. And I would say we start usually when we start the angles, and usually sometimes I'll say for beginners, we do use degrees. We do use degrees. One complete revolution, it is 360 degrees. The thing you want to understand here is when you are talking about an angle in terms of degree, you really need to say the word degree specifically. If you only say 360, it really won't make sense. I could say that's 360 days instead of degrees. So indeed, more commonly, especially I would say in mathematics, starting from calculus, or in physics, okay, in scientific world, when we use angles, when we talk about angles, we use the radian measurement. A radian measurement, it is a dimensionless quantity, which means a radian measurement really it is a single real number, a single real number. A number one could be a radian, number two could be a radian. But anyway, actually, believe it or not, in class, we don't use 1 radian or 2 radians a lot. Actually, we use some special form of radians in class. Because I hope you remember 360 degree in terms of radian measurement, it is 2 pi. It is 2 pi, okay. So you want to know radians very well. And because 360 degree is 2 pi, so according to pi must be 180 degree, okay. And also, I say as it is expected, you know how to convert between radians and degrees, and supposedly they are covered in pre-calculus class or college algebra class. And for me, for now, for reviewing purpose, I just listed out some conversions between special angles. So an angle of 90 degrees, that's pi over 2. An angle of 60 degrees, that's pi over 3, and so forth. And something a little big, 3 pi over 2 turns out to be 270. Okay. And that is the first part of reviewing for trigonometric functions. It's about angles. And the bigger part, it is about trigonometric functions. To make it simple, I suppose you know the very famous phrase, SOHCAHTOA. Basically, it says for trigonometric functions, sine of the angle, sine alpha, I denote the angle here, it is alpha. Okay, from the point of view of this angle alpha, this side, it's the opposite side. And the side line segment AB, it is the adjacent side. And certainly the longest side of the right triangle, it is the hypotenuse. So the SOHCAHTOA phrase simply says, sine alpha, it is the opposite over the hypotenuse, SOH. SOHCAHTOA cosine, it is the adjacent over the hypotenuse. Tangent, it is the opposite over the adjacent. That is the meaning of the SOHCAHTOA phrase. I know you must have this from high school or even sometime earlier or somewhere else. But you really want to know, actually in college, this phrase still it is very helpful. So I have the right side, okay, the graph to the right. It is a similar drawing. It is a similar drawing. As you can tell, now I'm having angle alpha. Okay, clearly it cannot be fitted into a right triangle. But anyway, I just want you to know for any angle, okay, you put the angle into the x1 plane, you always can create a reference right triangle. So the reference right triangle, it is created from the terminal side of the angle. You pick a point from the terminal side of an angle, then draw a perpendicular line back to x-axis. So instead, actually, I did put a dotted line there because this is the line what I added. Then with this dotted line, I hope you see the right triangle. The right triangle. This is the reference right triangle. And this clearly, when we are working on this angle alpha, so accordingly to match this angle alpha, I believe this would be the angle inside the right triangle. It is the supplementary angle. The sum of two angles equals 180 degrees equals pi. That is supplementary angle, correct? So you look at the supplementary angle inside the right triangle. With respect to this supplementary angle, the y-coordinate, it is the opposite y. And x is the adjacent side. This r, it is the hypotenuse. R is the hypotenuse. So now, as I'm saying, based on this same SOHCAHTOA phrase, basically you want to consider when you have an angle which cannot be fitted into, will not fit for a right triangle, you can use the same SOHCAHTOA phrase, but anyway, you really want to be very careful. It is based on the so-called reference right triangle. So sine, it is the opposite over the hypotenuse if you consider the supplementary angle inside the right triangle here. But this time, the opposite side, you want to be very careful. It is recognized as the y coordinate. So it is y over r. This sine is the ratio of y over r. This is more generalized, and it is the standard definition of sine. Similarly, cosine, it is adjacent over the hypotenuse. X is the adjacent side with respect to this supplementary angle. But with this angle alpha, it is the x coordinate of the terminal point from it is the point from the terminal side of the angle. So cosine, and then tangent similarly. Sine, cosine, tangent. I'm seeing clearly they all are derived, okay, based on this phrase, SOHCAHTOA here, SOHCAHTOA. And then you may wonder, we do have other trigonometric functions, right? There are other 3 trigonometric functions. So this is just for reviewing purpose. I want you to know cosecant is the reciprocal of sine. Secant, it is the reciprocal of cosine, and the cotangent, it is the reciprocal of tangent. So if you know those arrangements, and especially if you know the SOHCAHTOA very well, hopefully it's not that hard to follow the trigonometric functions, And also, I have 2 special right triangles for you to remember, because many times to consider trigonometric functions, we need to have the exact function values. I'm checking the time. I guess I need to take a break first. I cannot make the video too long. So let's take a break, and I'll see you next time. Thank you for watching.